I guess I should start off. My name is Max. This channel is about my shop and the various projects that go into it. I figured I'd make a little introduction at the beginning just to kind of, show where I'm coming from and things like that. I'm 19 years old. I have very little experience in anything other than what I've taught myself over my years of existence, which of course aren't very many. So for the most part, the projects that I do, I have to learn a lot about. I enjoy learning a lot, and so I believe at least that's one of the reasons I enjoy working on my project so much. I try to keep projects going as much as possible, and hopefully I will continue to upload these videos over time. But of course, as most of you probably know, it's very difficult to film and work on things at the same time, but I'm hoping that I can get past that hurdle and do things well. So yeah, I think that's probably a pretty decent introduction to me and my ethics about the shop. I'll give you some details about the shop. It's you can see it's just a big old pole barn. It was made in 1973. Has a stone floor, which is not ideal, but I do have an actual workshop over there, which has a concrete floor and is insulated, has a furnace and all. And that's where the majority of my tools are. This barn section that I call it, the barn here, is mainly just for the storage of my projects and things of the nature. Of course, I do still live with my parents, so not everything that's in here is a project. Right now, I think pretty much everything is, but normally this barn is far more filled in. So usually there'll be a lawnmower here and a load of 4x4 side-by-side there. So yeah, this is, you can see him walking around in the background. This is my shop dog, Macker, or Mac, like Mack truck. He is a red wire-haired miniature dachshund. You'll probably see him featured a lot. He's a great little dog. He doesn't bark, but he knows when to get out of the way. So so that makes him a pretty damn good shop dog. So anyway, I guess what I'll do next is I'll go ahead and take you off of there and take you for a tour around so you can see everything, and then I'll introduce you to the first project. Okay, so starting off where we just were, you can see I haven't changed anything yet. My little seat's still there. This is the barn section. See what's going on in here. Like I said, it's just a big old pole barn. It's not even that big, honestly. It's pretty small compared to most, but it's pretty big for me. So yeah, that's pretty much that part. So next is the workshop. You can see the stuff laying all over the place. Air compressors and stuff. The workbench is completely cluttered. One of the first projects that I'm going to do here is getting this place cleaned up. It's pretty awful. I just got back from college, so it's going to probably take a while to get everything cleaned up. This isn't my doing, thankfully. There's the furnace. It is Stanley. It was put in when the barn was put in. So I don't know if there's a year or anything, but that's what it is. These shelves are the first thing I cleaned out in here, so we'll have to get on that. This was my old grandmother's clock. She had it at her lake cottage, and so I put it up there. Tell us the time. It's probably not accurate. In fact, I know it's not. So, now some of the features of it. This here, which you probably saw, this is a 1952 Atlas horizontal milling machine with a Rusnak branded vertical mill head. I have a ton of bits here of tools to use for it. Lots of end mills and all kinds of things. Down there in those boxes and in random places all over the place, I have multiple different tools for the horizontal section. The horizontal section needs some work. The the automatic drive, which is back here, I do have it, but the plate right here has been broken, so that needs to be fixed. I'm going to send it off to my my cousin. He has a machine shop out in Idaho, and he can mill me a new piece of aluminum to the same spec. So that's the mill. That's the big tool in here. You can see I've got normal things: the chop saw, the band saw, grinders, blah blah blah. You know, normal shop things. The mill is probably the only big thing. Harbor Freight welder, I use that often. You'll see me use it often. I'm not the greatest welder in the world. In fact, I don't think I'm even half as good as the worst. But I can get a weld, and I can get it solid, and it doesn't have holes in it, and that's all that really matters to me. Continuing on to the next things, of course, I have lots of areas to hang things, but that's not really a function of the barn. That's just the way it is. The next real big thing is my whistle. This is a 1903 Buckeye Brass 4-inch 3-chime steam whistle. It rings a minor chord. I don't remember what the notes are, and I just have it set up on air. It runs 123 psi right now. But yeah, I just got it set up with a metal cord going up into the barn, and if I go back inside, you can see the whistle handle here. And that's pretty much that. So yeah, the next time I pick up the camera, I'll be introducing you to the first project, which will likely be this. Okay, so I'm back again. As I said, this next time will be introducing you to the first project, which is my boat. I want to make sure that I want to make it clear for myself and for others that all of the things that I'll show you in this series, on this channel, are either mine, as in I legally own them, I have them written in my name, or I am catering them. I'm their custodian, basically. For example, the sport bike over there is technically speaking not mine. Not even technically speaking, it is not mine, but I am its custodian for the summer. So, yeah. But these things that I will show you are mine, especially this boat. And I bought this about a year ago. It was one of the first things, one of the very first things that I had written down in my name when I turned 18. It is, I know you can't see it fully, but I'll give you a better view from there. It is interesting doing this for the first time. I kind of recognize why it's so difficult, because you just try and hold the camera in a comfortable spot and it just looking at nothing. So, alright, anyway, this is a 1969 Sea Sprite. I know nothing about the company, the Sea Sprite company. I just know that they made some pretty beautiful boats, in my opinion. Certainly not in very beautiful colors, but very beautiful boats. I mean, it just has such a nice line to it. It's a very pretty little thing. This is a horn, in case anyone's asking. It does not work, at least not as of right now. I'm hoping that maybe I can get it to work, but if I can, it's not that big a deal. It is powered by a Johnson EL71B, the 71 meaning it's a 1971. It's electric start. It's carbureted. That's my specialty. And it does run. At first, when I first bought it, it was pretty darn close to being seized. It could move a little, but it mostly didn't. It would not go all the way around. So I took the cylinder head off and got a whole bunch of gunk, what looked like dirt or something, I imagine what happened is they hit a sandbar and the water pump started to suck up dirt. And it must have had a bad head gasket at the time, and so dirt just kind of got in the cylinder, which is good for me because it was easy to clean out and the thing was fine. The cylinder walls were in perfect condition, which I thought was ridiculous seeing as the amount of dirt that was in there, but they were fine. So like I said, I took the heads off and cleaned everything out, and then I made a new head gasket for it, although they do exist, and I did buy another one. This one that's in it right now is custom made. Then I put the head back together. Had great compression after that. Turns over just fine. I'll show you. Turn it over by hand. Of course, you can see the compression. If I can get a good grip on it, you can see that it does in fact turn well. And if I were to pull the plugs, it would turn very well, but yes, it does turn. If I kick over the prop, there you go. Lots of compression. So anyway, there's that. It's a twin cylinder 2-stroke. If you couldn't tell from before, there's no valves. It's just ports on the inside of the cylinder. And like I said, oh no, I didn't. Never mind. Not like I said before. We will be getting into this. This series about this boat will be a many multi-part series. God knows how many videos will go into it, but basically the plan is to make one video for every or so half hour of work on it, and just kind of detail what's going on. Maybe not so much a half hour, but every part of the project. So like if I was going to dig into your vacuum switch here, that would be one video sort of thing. I'm hoping that it works out because I've done stuff in the past with really long videos, which is the way I personally would want to watch it, but they never get views, and it's not like I'm trying to get views, but I do want somebody to watch it. Not because I'm selfish or anything, but instead because I think the stuff I do is pretty cool, and I want to share it with other people. I feel that a lot of people my age don't know anything about the stuff that can be done with these machines and the things that can be done with very little money. I mean, I bought this boat with the trailer and the engine for $300. So I want to share this with people and hopefully get people into doing stuff like this. I feel like the world would be a much better place. And there goes the compressor. I feel like just my generation would do much better if they had a little bit more knowledge about this kind of stuff. So anyway, back to this. So yeah, cleaned out all that, had no spark. For a long time I couldn't figure out why. I bought all the parts for it. I bought the coils and the condensers and new points and everything. Turns out the points were what I needed. The little non-conductive bars that went in between the points were not. They were conducting somehow. I don't know exactly how that happened, but they weren't shielding anything. They weren't being insulative against the points. So you had constant ground from the points and therefore a constant circuit. If anybody knows anything about points, which of course we'll get into eventually, at least how I know of them, that they when they have a constant ground, you have no spark. You have power, but no spark. And power doesn't necessarily mean anything unless you're tapping off it, which of course this boat is not. There's no charging system on this boat. Probably could do one, but it's not really that necessary, honestly. It's such a small engine. It's only 40 horsepower. So, yeah, so that's pretty much that. I dug in, got those, replaced the points, adjusted them, put in new coils anyway, or excuse me, new condensers anyway, used the original coils. The new coils I still have as backups, which is probably a good thing anyway. The starter motor works just fine. It's the same one that was on it from the factory as far as I know, and it has no problems whatsoever. Also, the solenoid, at least originally didn't, but I was trying to get it started last week and it crapped out on me, so I got a brand new one. You can see, I mean, it does not look nice. That band is pretty disgusting, and this rubber here is just about ready to fall apart. So if you can see that, pretty disgusting. But there's nothing technically wrong with the outside of the solenoid. It's just that band and the rubber. So anyway, it went dead, and so we're going to throw that out and put a new one on. Might save it. Maybe I can rewind it in the future, but probably not. The wiring in the boat is horrendous. I mean, I don't know what the person who owned it last did with this stuff, but it's so tangled and disgusting, and it just goes everywhere. I mean, it's not even organized by any metric. The only wires that are organized are your shift lever and your throttle lever, or throttle cable, excuse me, the two cables for the shifter and the throttle. I guess they tried to be organized at times, but it didn't work out. I don't know if this is this is the zoom. You can see there, if it'll focus, those are splices. They are not soldered. They're not crimped. They're not anything. They're just two wires stuck together and then electrical taped in the middle. While that might be good for some things, that is what drives the horn. That wire right there is what drives the horn, so that's actually drawing quite a bit of current. Hence the reason I believe the horn died, is that it just was not doing well, and one of those wires melted. So so that's what I'm thinking, but we'll find out. We'll find out over time. The reason the floor is out right now is because the previous owners cut the floor out here. This big square, you can see I've got tons of stuff in here, but this all the way up to the front, they cut the whole floor out of the thing so that they could mount chairs to the stringers. Which I guess is probably good because they were stable at the time. The problem is, of course, is that the floor that they put in afterward was not fully sealed. It was just bolted down. In fact, most of it was just laying in place. So water got in over time and rotted the crap out of the stringers. So they need to be replaced. And so my idea is, I'm hoping at least, that they don't tie into the transom. This is a completely fiberglass hull. There's no wooden supports or anything in it, so the only reason it's strong is because of its shape. So I'm hoping that those stringers just put weight down on the load-bearing parts of the hull that can actually hold up the weight from the inside, rather than tie into the transom. But we will find out. If that's the case, then the job will be fairly easy. Cut the top off of the fiberglass here, remove the rotted and destroyed wood from it as best as possible, build new stringers, put them in place, and fiberglass them in. Hope to God that it seals up properly this time. Then, of course, I'll have to build a new floor, but I'm going to have to cut the rest of this out first. Once I'm done with that, I'll fiberglass over the top of it, seal it up so that you can't get water in there anymore. And hopefully at that point, it will be ready for at least a sea trial, for a test in the water. And yeah, so that's basically the plan with this thing. I don't think I have any other information, except for, I guess, just the rest of the plans cosmetically. The Cox trailer that it's on is going to have some restoration, but for the most part it's okay. The tires that are on it aren't dry rotted. Probably could use a new jack. That thing's about 1,000 years old, which of course there's nothing wrong with being 1,000 years old as long as you're still working. Obviously it's not doing so hot. Excuse me. Anyway, then the rest of the stuff that's metal on this, the windshield and things, are going to get taken off and polished, buffed up. Probably polish the windshield so that you can actually see through it. That is not just stuff on it, it's just that, it's not transparent. Transparent so you can see through it, so I guess it's translucent. It's translucent when you can kind of sort of see through it, when it's diffuse light. Anyway, that's basically what's going on there. So that needs to be polished up so you can see through it. Yeah, and then the top section that's green right now, that weird sickly mint green, is going to be red for the most part. And this stripe down the middle and along the sides here will be white. So you have red here on the sides and then white up here all the way down. So it'll kind of look like an old, Stingray Corvette or something with a racing stripe down the middle. That's what I'm thinking of, at least. The hull will be repainted in a nice, just plain white color. but a nice sea-resistant paint, a nice water-resistant paint that will that'll do well there. Hopefully it will also accentuate the fiberglass and make it nice and smooth, because as of right now there's lots of cuts and digs in it. So that should pretty much be that. The engine, I'm probably not going to paint very much. If anything, I'll touch up the main colors that are on it, but it's not that big a deal to me. For the most part, I'm function over form. So really, as long as things work, I don't care what they look like. But I do like to have something that looks nice every once in a while, and especially something this old and this to me at least, fantastic. I mean, I haven't even driven this thing yet. I've barely run the engine, and I love it with all my heart. It's just an absolutely fantastic machine. It's just a beautiful little thing, and hoping to God that I can do it the justice that it's done me. So anyway, so that's the introduction to the boat project, the 1969 Sea Sprite with a 1971 Johnson 40 horsepower engine, and its 71 Cox trailer, as far as I know, 71. And yeah, I don't have time to dig into it right now because I'm actually doing another project today, and I have to go down to the store. But as soon as I get the chance to start working on this thing, I'll throw the camera down and show you where we're at with it. Another thing I should probably mention before I continue is that I often have friends come over and help me out with my projects, and my cousin Carter comes down pretty much every year to help me out for a long time, for a good week, 2 weeks sometimes, to help out with projects. And this is technically co-joint our boat together. I paid for it, I own it, but he's my best friend and he's my cousin, so I just let him have it, basically, so that he can use it whenever he wants. But that's that. Like I said, I'll have people over, likely, and you'll probably see more than just myself working on these things over time. Alright, well, we're getting started here on the boat, my 1969 Sea Sprite. So just to give some background information on what we're doing today. This is the Johnson 40 horsepower engine. It's a twin-cylinder two-stroke. You can see the two plugs here. The magneto is up here underneath the flywheel. Like I said yesterday, starter works, all that stuff. Just to, oh yeah, by the way, today is tomorrow. Today is the day after I made the intro to this video. I had a lot of stuff to do yesterday. We were cutting down some trees, and we'll get to that project later on. But today I'm free, so I'm going to be working on this today. So the first thing that we're going to be doing today is rather simple. These are the basically cutoffs to the ignition system on this boat. Each one goes to one of the sets of points, one of the two sets of points up here. So basically what this does is it grounds the points out to the block of the engine. So what that does is, like I said yesterday, it creates a continuous loop. So I should probably give you a small demonstration about how points work. So the simplest way of how points work is you have a coil, okay? The coil actually consists of two different coils, a primary and a secondary coil. The primary coil is very short and made of a thick wire. It's probably about, let's say, 10 turns. This is not accurate, I'm just a demonstration. 10 turns, right? So you have 10 turns and a magnet in here, in this flywheel, as the engine is turning, will pass that and induce a current in those 10 turns. Now, another thing that is in here is what are called points, and points is basically like a light switch. It's just a breaker that opens and closes. So imagine when my fingers are open like this, there's no continuity between these two, so power does not flow. But if they're closed, then power does flow through the system. So on this side, over here, if you can see, over here would be your coil. The magnet passes the coil, induces a current. That current flows through the wiring and back to the coil, right? This is a very simple demonstration, but I just want to get it over. So then you have, as that's happening, you have a magnetic field or really an electric field, that expands around the outside of the coil. Okay? Now, on the outside of the primary coil, there's a secondary coil, like I said. That secondary coil is about 1,000 turns. Remember, the primary coil was 10 turns. So you have the 1,000 turns here. Now, you have power flowing through this circuit, and you have an electric field that has grown around the coil on this end. When the points open and the circuit is broken, electric flow immediately stops. It just stops. The field that is generated around the whole system stops. And this electric field that has grown around the coil back here collapses, and it collapses at the speed of light. So that means that you basically have a magnet moving past this secondary coil, one with 1,000 turns, at the speed of light. That generates ridiculous voltage. Okay, unbelievable voltage, somewhere between 20 and 40,000 volts. Now, 20 and 40,000 volts at a very low current rating, like probably 5 to 10 amps, I would say, maybe even less than that in most situations. But anyway, extreme voltage, which of course is what allows you to jump the gap of the spark plug. That ignites your fuel-air mixture, creates an explosion, boom. That explosion creates huge amounts of gases. Those gases occupy the same space as before in this cylinder, creates very high pressure. That pressure acts on the surface of the piston, forcing it down, creating rotational motion in the flywheel, which is then stored as its inertia. And then that inertia is transferred through the propeller shaft, down to the propeller, into the water, and moves the boat. So that's the basic demonstration of how points work. So if you never have those points open and cut the circuit, you will never have the field collapsing at the speed of light around the secondary coil, and therefore you will have no spark. So these, okay, if you leave them like this, completely unconnected, the engine will always fire, which is in its current state. The reason I did this is because I just wanted to get it running and just make sure that there was nothing else going on that was limiting my spark. And so when I did, it ran and that was fine. Now, we want to be able to turn it off. So the first thing we want to do is we want to hook it up to this device. Now this device is a vacuum switch. It basically has a diaphragm in there. And when the engine draws a large vacuum, the diaphragm gets sucked against another breaker, another light switch, right? When those two contacts connect, when the vacuum from the engine is high enough, this post here that I'm pointing at becomes a ground. Okay, so right now it's not attached to anything. There's no ground. But when the vacuum is drawn to a high enough degree, this will become a ground. So these will attach on here. Of course, I have to change the fittings that are on them. But these will attach on here and make it so that when the engine draws a very large vacuum, in particular in this edge, at an RPM far higher than it's meant to run, it will cut the ignition. So it's basically a rev limiter. When the vacuum's high enough, it'll cut the ignition, the engine will slow down. When the vacuum is then low enough for the engine to continue running, turns the ignition back on, engine accelerates, blah, blah, blah. You get the point. The only two events that would be necessary in an outboard, you think, well, why would you need a rev limiter in an outboard? Because it only goes as fast as it can go anyway. Well, what happens when you hit, a sand barge or something like that, and your shear pin on your prop breaks? Then all of a sudden, your engine instantly has no load on it. The inertia in the flywheel and the engine running at full power will immediately run this thing way faster than it's supposed to. So that's what this is meant to do. That will cut off your ignition there and will stop the engine from over-revving itself and obviously killing itself. The other thing, of course, is if you're really stupid and you try and run this thing out of water, or maybe if you have it in neutral and you just accidentally smack the throttle with your arm as you're trying to get out. I mean, it's a small boat. So all of those things are possibilities, and this is meant to save us from that. Now the problem is this one that I have here is non-functional. It's the original one that came with it, so it needs to be replaced. And I have a brand new one. I just have to run inside and grab it. So we're going to remove that today, put a new one on, run the wiring to put these on this post, and then we're also going to run the wire from the ignition switch up there to here so that we can shut the engine down with the ignition switch as well. So let's get to it. Not quite sure what happened there, but it shut off. I don't know if I'm out of space or what was happening. But anyway, yeah, so you have your ground post here. When your engine draws enough vacuum, that will become a ground and ground out your ignition system, so you have no spark. This is the nipple that the hose goes to for the vacuum. And down here, which you can't really see, back behind there is where the reed valves are, and that is where the other nipple for the vacuum is on the engine itself. So when the engine revs too fast, obviously it'll be sucking in a lot of air, and it's likely that the carburetor size won't be able to supply that air. It's also likely once something like that happens, you'll try and at least pull the throttle back. So that'll draw a huge vacuum and shut your ignition off very quickly. So yeah, that's the basic principle of that. I can feel the diaphragm vibrate when I do this, which is actually really cool. I don't know if you can hear it. I don't know where the microphone on this camera is, but I guess just take my word for it. When you hit this, you can feel a small vibration, kind of like a tuning fork in this device. So it's really cool. Okay, so I'm hoping to whatever, I guess, that my card is not running out of space, because I can't tell. I'm not educated enough to understand this camera, which is my father's. So anyway, we're going to start by removing everything on this. I'm just going to take it right off the engine block at first, and then we'll remove this post over here. I believe this wire is meant to go to this post, which is connected to a micro switch up here. And that'll probably have to be solved another day, but I'm thinking that this is likely a micro switch for the ground here. Not sure what this ground is for, but I'm going to imagine that it goes somewhere to the starter or to the solenoid for the starter, because this micro switch turns off at anything more than low RPM. And I imagine that's probably so that if you accidentally have the throttle up, you can't start the engine. So that's my theory. Anyway, we're going to start by removing these bolts here. They're just flathead, which is why I have the flathead screwdriver here. Nothing too special about them. For now, I'm just going to dump them in here. I'll likely have to get new ones anyway. Like I said, the kit that I got does not come with screws, and we are missing one. The previous owners of this boat were not very good custodians. However, I did have a quick chat with the guy who previously owned it, and apparently this boat was his father's baby, which it really makes me want to fix it up more, because, you know, if somebody at one point cared about this thing enough to do all the things that have been done to it to keep it alive, you know, I'm really envious of them, even if they did it wrong. Well, objectively wrong. Wrong in the sense that it shouldn't have been done like that so that I could fix it in the future, but less wrong if it was just their machine and it's just like, well, don't have the money or tools to fix it now, so I might as well just do what I can with it, and that's, sometimes it's all you can do. So I'm just getting some tools right now to remove that nut on the ground post there. I'm just going to use these, or attempt to use these. Thinking about the wrong way to do things, this would be it, but at the same time, it's the easiest way to do things, and I think it'll probably come off pretty easy. Yep, I was right. It's going to be difficult to have you see everything, but it's off. Okay, so there's that. And where this was connected, or at least where I believe it was connected, is just underneath that bottom bolt, but I have plenty of those connectors, so I'm just going to get rid of it. And there goes the compressor. You can see here where the cut has been made out of this. I don't know if it was cut on purpose or if it was just broken, but yeah, that is definitely not a good thing. And like I said, the diaphragm in there is stuck. When I hit this one, no feeling of anything, no tuning fork feeling, no vibration. So so this is definitely not a good unit here. Okay, and now I have you just a few feet away over at my tool bench. which is rather crowded right now with other projects. Most of the stuff is going to get put away today. But anyway, I just want to go over this, and I want to check to make sure that, I know I can feel the vibration in there, but I want to make sure that it will actually seal properly. And how I'm going to do that is I'm basically just going to attempt to use my mouth to create a vacuum on that and see if that will ground together. But in order to do that and have you see it, I'm going to have to go get a hose of some kind that I can connect up to it, so I'll be right back. Okay, and here we go. Got the cheapo Harbor Freight multimeter set up here. Can you see that? Nope. No, you cannot. What if I put it over here? You see that? Nope, you cannot. How about here? You see that? Yes, you can. Alright, let's try not to move anything so that it falls over. So I've got my hose here, and this I'm just going to suck on the one end and close that diaphragm. Should be plenty enough vacuum to do it. And we're just going to put one lead of the multimeter on the ground post here and one on the ground to the engine. And yeah, it's pretty much that. Okay, so no vacuum. And now I'm going to create a vacuum. And there you go. You can see we have a connection there. That is our ground being formed. That's exactly the way we want it to be. And just to show you I'm not lying, here is the old one. We will go ahead and put our two leads on there the same way as before. I'll create a vacuum with my mouth and we'll see what happens. As of right now, no connection. Oh, never mind. Connection? We might have a connection. Do in fact. So that is closed. It's stuck on ground. I could probably take this apart and redo it, but it was rather cheap to purchase on marineengine.com, so just got it on Marine Engine. But it's probably good to save this anyway, because it's likely that, like I said, I could fix it in the future, and rebuild kits exist for these. So I'm just going to throw this in my save box, and in the future, if I need it, we can put it on. Okay, so we're back over to the engine. Just went through my little box of goodies over in the workshop. This is the original screw, or these are the original screws. And if I take one, I just found this other one there, which is a similar size, slightly shorter, but it's not that big a deal. And they're the same thread pitch and size, so that's the important factor. So I'm going to use those to install this new one, and hopefully I can get to the other nipple over on the side of the reed valves. So we're gonna go ahead and put this on now. Oh, and I need my screwdriver. Can't do a job without a tool, right? So anyway, this is gonna go this way with the nipple sticking down. If you don't remember, we got our first screw here. It's gonna go right up into here. Trying my best to allow you to see here, but it is rather difficult to work around the camera. So there's the first screw in. And there's going to be the second one. Go. And the third is going to go right down here. If you can't see that, it's right there. And there we go. All three of them are decently tight, not ridiculously tight, but decently tight. So that is now a good switch. Okay, now this is going to be real fiddly. You can see I've got the hose hanging out in here. I'm going to try my best to get it on the nipple on the reed valve side real quick. Just need to grab a pair of pliers, which are on the other side. One moment. So I'm going to actually move you a little bit here over to the back side of the engine so that you can kind of see a little bit, hopefully. So here's our hose right there, and back here is where we're trying to get to. So I'm going to have to get in here. You know what? Actually, let's put you in the boat. That might be a better shot. I have no idea what it is you're seeing right now. Where are you pointed? Over this way a little bit. So let's turn you just a tiny bit. About there. Can you see? Oh, you're a bit tall. Okay. Okay. Let's get you angled down a little bit. Oh. There we go. That'll probably be decent. So here is our hose right here. I'm going to try and pull it out here just a little bit. I want to make sure our hose clamp is on properly. Well, not properly, but on there so that I can get to it when it needs to be on there properly. I'm going to have to press it down a bit further. Let's try it now. Very fiddly here. Almost got it, but I'm going to have to bend it a little bit. This way. A little bit more. Okay. And a little bit more. Nope. That isn't going to work at all. We may have to do this the proper way and take this off. I really don't want to have to because it's a pain in the butt. Did it the last time to work on the carburetor. Just a pain in the rear for sure. Very warm today, about 80 degrees. The dog is laying down under the Kubota outside. So, if he's out there in the shade, you can tell how warm it is. In here, it's always warmer. Okay, there we are. We're on. That was not too bad, I guess. Wasn't horrible. Now I have to try and get the hose clamp on there. I have no idea how I'm going to tighten it. I might just want to knot. Might just leave it there. Don't know if you guys can see anything I'm doing, but It would really be nice if you could. Okay. And there we are. Hose clamp is on. How can I get to it? That is the question. I can, sort of. Not very well. Fiddly business. That's what this is. Okay. I think I'm moving my hose off, so let's make sure it stays on there before I lose it. Oh, that would be why. The reason this is so difficult is because the here we go. The hose clamp is loose enough that it'll rotate around the hose. But as you know about a hose clamp, the screw is only on one side. Now thankfully I have the screw in an area where I can always pick it back up. I have it on the bottom. If it was on the top and I pushed it back there, I'd never be able to get to it again. Only problem is, if I put any kind of force on it with it loose, it just turns around. Thankfully though, now I've got it clamped down a little bit on it, so I can continue to turn it without too much issue. Okay, and that should be on there pretty good. Okay, so now we just have to do this one here, which will be far easier. Far easier. Since I have full view and access to it. And that's just going to go on just like that. Okay, so that is the device installed. That means we can move on to the actual wiring. Okay, we're back down on the ground now. So you can see our newly fitted device here. It's in perfect shape for us to go ahead and use it. So one of the things that I've actually noticed is that this is completely insulated from the engine block, which makes sense. It has to be, otherwise you could have things that are not wanted getting to this here. But that means that this metal bit on the outside, this metal casting, needs to be grounded to something. Now, I don't know if this is a ground, so I'm going to have to check it real quick. But I doubt it is. I think this is probably the ground. And I'll bet you that microswitch works in the opposite direction I thought. Instead of it being on at low RPM, instead it'll be on at high RPM. And that way, whenever the engine is running at idle, when it's drawing a very large vacuum because either the choke or the throttle butterfly are closed, which at idle both are when starting, then this vacuum will not shut off the ignition. But instead, at any other idle position or any other throttle position, when that's on, that's connected there, and that will give you your shut off. So I'll bet you that's what it's for, which means it's likely I'm going to have to take the flywheel off to handle that. But that shouldn't be too big a deal. This flywheel is rather easy to take off, so we'll do that if necessary. But first off, let's get those two bolts out of our way and begin assembling the setup there. Okay, so moving on to the wiring section of the job, I'm going to go ahead and cut the ends off of these real quick. Okay, and these should be 16 gauge, but I'm probably going to have to go down one. Here we go. Okay, perfect. So that's that. Now I'm just going to go get some butt connectors, and I'm going to cut a little bit of extra 16 gauge wire for them. The reason I need to make them slightly longer, the throttle is all the way open right now. It's at full throttle. So you can see with the timing advance on the ignition, it's too far away to grab onto your ground post there. So I'm going to add a little bit of wire to it. It's not any kind of special wire. It's just some cheap wire, the cheapest 16 gauge wire I could find. And it's not like it needs to be anything special. There's literally like 12 volts, half an amp. No, 12 volts, a tenth of an amp, and probably more likely going through that wire. So not even going to get close to its maximum rated. So we'll be good on that front. Cut this, let's say about that long. Cut that in half. Let's see, is that long enough? Yep. That'll be good. I need something to grab onto this. Steal my my thing, my pliers here, just so I can grab onto it a little tighter. Can't grip it with my hand properly. Okay, there's that. Then we'll do the other side. I know you guys can't see this, by the way. Sorry, it's just rather useless thing to film. Everybody knows how a wire stripper works and how to use it if you've ever done anything with wiring before, so it's not that big a deal. And if you haven't, then maybe sometime long in the future, if and when I realize whether or not people are watching this, I will do a tutorial on it. Remember, everything that I do in this workshop is stuff that I've taught myself over time, so don't be discouraged if you don't have anyone to teach you how to do these things. You don't need a teacher. Your best teacher is yourself, after all, since you know how you learn. So. But anyway, now we have a good set, or good wire here that's ready to go. Basically, I'm just going to put a butt connector on that and then a loop connector. I'll show you that real quick. One of these here. Let me pull it out, sorry. There we go. One of these here. Like that, which will fit right over that post and get bolted in between those two. And we'll have two of them for these two, go into that. And then we'll have a third for this wire, or no, not this wire here, sorry, going to the starter motor. Alright, so I'm just going to finish that up real quick and I'll be back in a sec. Okay, so you can see the result here. Let me grab a light so you can see it a bit better, but and my lights decided not to work. Cool. I'll grab my phone's flashlight. That'll do it. So basically what we got going on here, you can see we have our, it's a bit overexposed in the camera, but we have our three leads here. These two are butt connected up to the two wires that go in there, and they're nice and heat shrunk onto the old wire here. And then we have the ground wire going to the starter switch. So hopefully that means when I turn the key on, we get spark, and when I turn the key off, we don't. So how we're going to check that, I'm going to line you up right here. I just took the plugs out. Line you up right here so that you can see it. Turn the engine over by hand, and hopefully we'll see whether or not it has spark. So let me set you down right there. Sounds about right. Let's see, can you see a plug if I stick it in? Should be able to. Okay, so we'll start with the key on. Just for yep, so it's on. Just to be correct about it. Make sure we have nice, clean, consistent spark. Okay, so I'm going to hold the plug right here and turn the engine over. Oh, maybe I should do it with my right hand. What's going on there? That's a weird noise. I don't know if you guys hear that. Appears to be coming from the transmission. Let me put it in gear. It works. But it's very noisy. Might have a seal issue there. Maybe we lost some of our oil. have to check that out. Okay, well anyway, back to our experiment with the plug here. Don't see any yet. A very large amount of resistance coming from that down there. An unreasonable amount of resistance. Might have a bad bearing or something going on. And it doesn't appear as though we have spark, although I may not be grounding it properly. See, I should definitely be getting spark there. Let me turn the ignition key to the off position. See if maybe something's wired up backwards up front. Nope. Okay, so we have a ground somewhere in the line. Let me go ahead and take the ignition key off of the bolt there. See if that changes anything. Okay, so I've removed the ignition wire. I don't know if you can barely see that off in the corner of the screen. Removed that wire from our ground post here and turn the ignition back on. Let's see if maybe we get spark now. Don't appear to be getting anything. That's odd. Let's take the multimeter out. See what we've got going on with this here. No connection there. Oopsies. Let's check the meter. Meter's working. Okay, so definitely no connection between there and there. How about... that's not good. Somehow we have a connection between this here and the engine block. How is that occurring? That is interesting. That should not be the case. How about between here and here? No, nothing there. But between here... now it's showing there isn't a connection. Now it's showing it is. And it's showing there is. So there's some sort of connection between this and the engine block. I'm wondering almost if it's because one of the points are closed right now, which would allow that. Yeah, that would allow a connection to the engine block. So that makes sense. That probably should be like that then. So why don't we have spark? I mean, the entire backplate of this device is plastic, so it's very unlikely that there's something escaping through it. And the bolts I used are not touching the case housing here at all. So, I mean, it would make sense that at least one of the points were closed at any one time. So that's probably the way it should be, but why are we not getting any spark? Like, I should be getting a very clear spark. Should be getting a very clear spark there. Something is clear. Oh! Now how are you supposed to do that? I think I understand what's going on. Remember what I just said about the two grounds being closed? It's likely that one of the points are closed while the other is open. With these two leads attached to the same spot. Okay, so sorry for the weird cut. Today is tomorrow once again, so this video has spanned the length of 3 days. The battery died, so that's why I cut off so weird. But what I was trying to say is, um, I made a mistake. And with the battery dying yesterday, I took the time to go and look over the footage and really noticed a major flaw in my thinking, and that is that when one of the cylinder's points are open, the other one is closed because it's generating power for the next spark, and they don't fire at the same time. They fire 180 degrees offset. So you have one fire, bang, turns a half turn, and then bang, and then turns a half turn, and bang. So whenever one is getting a spark, the other one is closed, charging up the circuit. Or, well, maybe not charging, but you get the point. It's closed. So you have a ground. And that means that if you put these two together, the one will escape through the other toward ground when it's open. So let's say, for example, remember my demonstration from yesterday where you open it, field collapses, you get spark, right? If you put this together, one of them is going to be closed all the time while the other one is open. So that means that when that point opens, instead of losing your circuit, it instead goes through this wire into this wire and back down through the closed circuit on the other side. And obviously that's a fault. That means that I get no spark when those two are put together. So I have the book, the manual for this engine, and so we're going to take a look at it and see if maybe they have an electric diagram or a wiring diagram or something of the engine here to see how they wired it up. Some of the possibilities which may be the case, I was thinking there could be an elaborate way of using this as a cutoff switch, because at idle, with the throttle all the way closed, you're drawing a lot of vacuum. So I'm wondering if maybe that vacuum is sufficient enough to close this so that the engine runs on one cylinder, and then you only attach one cylinder to the key, the other cylinder, and so that way one cylinder's dead when it's idling anyway, and you just turn the key and it shuts the other one off. That could be. I really think that's pretty dumb. It's a smart way of doing that, but I think running the engine on one cylinder all the time is a great way of getting hydrolocking to occur, or just, wasting fuel. But that could be the way it's meant to be, and I think more likely than that, there is a better way that this is supposed to be done that I'm not seeing. So we're going to take a look at the book. Okay, so here we have our book. I'm going to have to work around the camera. I'm standing right behind it right now, but I figure this is your best view anyway, so I'll just do it like this. Grab ourselves a screwdriver, get it open. So this is 1958 to 1972 Johnson Evinrude outboards from 1.5 to 125 horsepower and 1 to 3 cylinders. So that's cool. Got this book on marineengine.com like everything else. Really, really nice book. So let's go ahead and take a look at the at our contents, table of contents. We want ignition and electrical systems. Electrical systems, Ford 2, ignition, flywheel, distributor, battery ignition, CD, I don't have any of that. I just have our distributor magneto, I guess it would be. Or flywheel magneto, that's what it is, flywheel magneto. So if you can see that, it's over here on this page. Move the camera over just a little bit so you can see the whole thing. Actually, I should probably just move the book over. That would be smarter, wouldn't it? Hopefully you can read some of this. On my screen here, it looks like it's a bit too overexposed, but when I look at it in post, it's fine. So we'll hope that it's fine. Anyway, so we're going to look at electrical systems to begin with. That's 4.2. So let's see. Here we go. So 467, 412, 4.8. There's our ignition right there. 4.2, ignition electrical systems. Okay, so we understand that. So we don't have a battery charging setup, so we don't have to worry about that. Don't have to worry about that. Okay, nothing there. Okay, nothing there. Most of this stuff is talking about general electrical systems. Probably has to do with different systems on especially newer engines. Electronics are far more complicated on newer engines, hence the reason I deal with old ones. But, yeah. So we have our flywheel magneto right here. Let's see. This looks just like our setup, but I don't see that wire. Huh. Interesting. Okay. These are some demonstrations of what to look for. Degradation of spark plugs, blown coils, bad grounds, burned points, things like that. Oh, this is our runaway cutout switch, the vacuum switch we were talking about yesterday. So this is actually pretty cool. Let's take a quick look at this. This is how that vacuum switch works. So you have your vacuum pipe here, the diaphragm, which is mobile. Then you have your contact here. So when the vacuum is high enough, the vent in the back, just the weight of the atmosphere will press that diaphragm in, and it'll contact that. Well, it'll come in contact with the contact and ground that out, and so then you'll have a ground to your magneto, which will cut off your ignition. So that's pretty cool. It gives you a pretty decent idea of how that works. Just looking around to see if we can figure out where this lead is supposed to go to. This appears to be it. The ground leads, it says. Where do they go to? I know I'm being a bit quiet here, but I'm just trying to read quickly. I'll probably cut some of this out until I figure out what everything is and where it's going. Okay, so this is your distributor now. I just want a diagram of how it's supposed to work. That's all I want. Okay, well here's something. Oh, see, so that's different. That grounds out your coil. Could that be how it's supposed to work? Let's think about this. Would it stop if it was grounded? No. No, so if you think about it, if you have your one coil, the primary coil is already grounded. It's grounded straight to the block. And the other lead of the primary coil goes to so you have one lead going to ground. It's bolted to the frame. You have another lead. Which is the green lead that goes to your points. Alright, I'm going to cut the camera off before I run out of space. I'm just going to think about this for a minute. See if I can rack it through my mind and see if maybe that'll work. If it will, then I will explain it to you later. Okay, so as far as I can tell, that would not work because it's basically the same setup as I have, just in a different orientation. So, and the thing is that the killing one of the coils is not the problem. If you ground out either of the wires, it kills the spark. That's not a problem. The problem is that putting them together so that they're controlled by one wire means that you ground out both plugs and they both die. So that's the bad thing. And that's not really that big a deal because I could just run two plain old switches, plain toggle switches up front when I'm done with the boat so that I can turn each cylinder on and off independently, which, you know, you're always going to have both of them on or both of them off, but, you know, I've always liked airplane cockpits, you know, how they have all the different, you know, they have all the toggle switches, like 8 of them all over the place, so it'd probably be pretty cool. So if that's what we have to do, then that's what we can do. It's not that big a deal. I'm just trying to figure out how they originally had it wired up so that I can see. But this distributor setup is not correct. It would not work for my boat. So I'm going to look. I think I saw a diagram back here of a boat. I wonder if maybe, just maybe, there was something in there that I missed. So here's I don't know if you can see this. Here's the setup, okay? This is what the diagram that I saw originally and then took a look at. So you have your coil here, okay? You have your primary coil, which is the big thick one that's short, and your secondary coil, which is thinner and much longer. So your primary coil, the magnet passes it, induces a current. That current flows around here, okay? Around this bold black wire here. These are your points, and they break the circuit. You break that, then you break the circuit between here and here. This is your key switch. It's directly attached to the points. When you close that key switch, that grounds out your points so that every time the points open, you still have a ground, and so you never lose you never get ignition. This cam will open these points when necessary, lose the current in the primary coil, drop the magnetic field, collapses at the speed of light, creates an extreme voltage in there, which is then you have a ground here and your spark plug. The spark plug's connected to the ground with its threaded into because it's threaded into the block. So you have your electricity jump the gap there. So that's how that setup is supposed to work. And from what I can see, that key switch is connected right to the points, and that works. You connect the key to one of the points, and it's fine. It works. Problem is when you connect them to both, because then you have the 2 points in contact with each other, and like I said before, they ground each other out. And that's an issue. That is an issue. So let's see here. Yeah, so this, I mean, it says it is a wiring harness diagram for the boat, but it's, it's not, doesn't go into detail on what, it just says wiring harness from engine. So, obviously that doesn't help me. Well, I'm going to keep looking. I'll get back to you. Okay, so I found something interesting, which sort of supports my theory. You can see here, you have your 2 wires here. You have one coming off the points and going to here, to this connection. You have another one here, the bold black one, and that goes to the cutout switch. And then you have a safety switch here, which is on one side grounded to the power head, and one side goes to the ground post here. And you have a wire that comes back. This wire, black white stripe, 18 gauge, this wire follow here. Goes to the solenoid. Okay, so that's your ground for the solenoid, okay. Makes sense. And this black and white striped wire goes to your key switch. So I was correct in saying that the cutout switch cuts the one cylinder, but does it cut it at idle? Okay, well that fixes their problem at least, because that means we know where we're supposed to be going. So we can fix that. We can set it up so one of them goes there and the other one goes to the key switch. That's not a problem. Will it work? That is the question. It'll definitely cut one cylinder. When I turn the key off, it'll cut one cylinder, guaranteed. The question is, will the cutoff switch cut one cylinder? And the other question is, will it idle only on one cylinder? If it does, then that really completely eliminates the need for the fuel pump, because the fuel pump running on both cylinders way over fuels the engine. I mean, it's just pouring gasoline in there, which is one of the major problems with this engine. So why do we even need the fuel pump? Could be that we don't. Okay, let me think about that for a little while and I'll get back to you. But in the meantime, I'm going to put those together the way that says there. Okay, so I'm struggling a lot here. Just plug this in. There is still a connection somehow between this and ground. I'm not sure if I'm reading the connection going back through the magneto to the ground on the points, but yeah, I don't know. It appears as though we're still getting ground somehow. This also has ground, even though the key switch is on, which is obviously not correct. It's not the way we want it to be. And because of that, we're getting no spark on either cylinder. I'm going to try just removing one of these. Just take this off and see if we can get spark again on one cylinder. Oh, but somebody's calling me. Give me a second. Okay, let's get back to it. Just going to pull this right off. Just leave it right out in the open. See if maybe now we get some spark on something. Okay, nothing on that cylinder. Could be that cylinder right there that I was just testing, so I just swapped the plug over to the other cylinder. And we have spark now. Okay, so yep, so this being grounded is definitely an issue. No idea why it is grounded. Not sure about that one. Doesn't make any sense to me, as there's no possible way for it to be grounded. So, plastic, for the most part, there are some plastics that are, but for the most part, is non-conductive. The whole back plate of this device is made of plastic. That plastic does not touch the metal anywhere. How is it physically possible that this post is grounded? How is that possible? There is no contact between this and the engine block. How is that possible? All right, I'm gonna remove this. See what's going on. All right, well, I've made a discovery. I have no idea of its relevance, but there are metal screws on the back of this. Can you see that? Yes, you can. These 4 screws. I'm wondering if it's possible that one of them is coming in contact with the engine block somehow. So what I'm going to do is I'm going to get some electrical tape and cover those up and then screw it back on. Okay, so I've put in place electrical tape over those screws on the back plate. Maybe somehow something was leaking through, and I'm going to stick the multimeter on there. Don't know if I'll be able to get you to see. Maybe. You guys see that at all? No, you cannot. Okay. Can you see it now? Maybe. Move it forward just a little bit. So you can see that. Can you see where I'm going to be? Yep. Okay. Okay, so the positive lead I'm going to stick right here on our post, and the negative ground. No connection. That was it. That was it. Beautiful. All right, perfect. Let's stick a plug in there and see if maybe we can get some spark finally. Remove this bolt here. Come on, consistent spark. Let's see. Let's get you over here where you can see, hopefully, what's going on. Got my spark plug right here. Hopefully you'll be able to see this. Don't know if you saw that, but we have consistent spark. I can even hear it. That is beautiful. Okay, well that's one problem solved. And honestly, it's probably a decently permanent solution. As far as I know, electrical tape doesn't melt, and plus this is a liquid-cooled engine, so it won't get over 212 degrees, likely. Unless this is the exhaust side, which probably is, and that's probably going to screw me and light my boat on fire, but whatever. It's just my luck, eh? Anyway, so the next thing is to figure out why our ignition switch is grounded even when it's in the on position. Which isn't really that big a deal because, like I said, I can just get a regular switch. But yeah, we'll figure that out. Anyway, I think for now that is a pretty good end to a video because, after all, this is the thing that we have been trying to do this whole video, is just to get that working. We can worry about the switch some other day, but I think for now it's okay. We got that put together. We got it working properly. We got spark on one cylinder, the cylinder controlled by this. So I think that's going to be it. I'll probably do an update once I get inside just to end off the video properly. But yeah, we've got lots more projects to do on this. Anyway, I'll see you in just a bit. Well, hello again, and welcome to our humble abode. Just for a bit, I just want to end this video off properly and say that while this was a difficult mental thing, just running over the possibilities of what was going on, we pushed through it, and we got that vacuum switch working. So while the project probably should have taken 15 minutes, took 3 days instead. But ultimately, this video is more about 2 projects. One, of course, about the project that is the task of the video, putting that vacuum switch together and getting it to work, but also just doing the video in general. I've never done this before. I've never filmed myself work, and while I've filmed the outcomes of work that I've done in the past, I've never done anything like this. So this was a project on its own, just getting this video filmed, and I'm sure it'll be even more of a project getting it put together. But just wanted to say thank you for watching. If you did, well, if you're here, you did. But I hope you enjoyed it. It was quite the adventure. I'm probably gonna have to cut out so much film because it was a lot of stuff, a lot of time. So, but anyway, like I said, I hope you enjoyed, and I hope you'll come around next time for when we're working on the next part of the boat. So, anyway, thank you again, and I'll see you later.